Okay, so I'm trying out a different microphone today. So we're taking a look at 5.2, but before we get there, let's take a look at a problem that is similar to one that we did earlier, and that is I've got this function y equals 2x plus 1, and I want to find the area under the curve between 1 and 3, and I want to use it, or do it two ways. Method 1 will be to use geometry. Okay, because we have some nice triangles here, we could go ahead and find the area of the large triangle, right, and then subtract off the area, of the small triangle. And so the area of the large triangle, let's see, what's this value right here? I believe that's minus 1/2. Right, so this size here is 3/2. And the full thing is going to be 3.5. So that's 3.5 there. And then, let's see, this height right here is going to be 3 times 2 plus 1 is 7. And this height right here will be 1 times 2 plus 1, which is 3. Good. And so now we're set. So the big triangle has area 1/2 base times height, or 1/2, let's see, that's 7/2 times 7. We subtract off the purple triangle area. That'll be 3/2 times 3. And so that looks like 49 minus 4 over 2. 40 over 4. Sorry about that. 4, which is 10. Good. All right, method 2 is the algebraic method here. We're going to use n rectangles to approximate the area. And then take the limit as n goes to infinity to get the exact area. Okay, so let's see, n rectangles going between 3 and 1. Let me get rid of some of this other stuff here. So the width of each rectangle here is going to be the width of this interval divided by n. And so the width of the rectangle, is going to be delta x, and that's b minus a over n in general. And in our case, it's 3 minus 1 over n, which is 2 over n. Good. Now if I look at this interval, I'm going to spread it out a little bit more. I start at 1 and I end at 3, right? And I go out 2 over n is the width, right? So if I go out 2 over n, my first right endpoint is going to be 1 plus 2 over n. Then if I go out 2 over n again, my next right endpoint is going to be 1 plus 2 times 2 over n. And the next endpoint, with another width of 2 over n, is going to be, you probably are starting to guess, 1 plus 3 times 2 over n. And so the ith right endpoint is going to be 1 plus I times 2 over n. Okay, and that's where we're going to evaluate the function for the height, right? So if this is my sample rectangle, this is the right endpoint right here, right? And so I'm going to lift this up, and that's going to be the height of my rectangle, right? And so I'm going to be using overestimates. And so the height of the ith rectangle is going to be f, generally, of 1 plus 2i over n. And our function in this case is the 2x plus 1, right? So that's going to be 2 times 1 plus 2i over n plus 1. So if I simplify that, looks like I get 2 plus 4i over n plus 1, which is 3 plus 4i over n. Good. Now, the area using n rectangles is going to be the sum, I equals 1 to n, of the height which we called fxi star. So this is the ith right endpoint now, but in general that's an undetermined quantity somewhere in the ith interval. Okay, times delta x, and we've computed these values now. That's going to be 3 plus 4i over n, and then the width is going to be 2 over n. Good. And now it's good to do a little bit of algebra before you take the limit. Oops, how did that happen? Let's try that again. Hope I'm not going to make anybody seasick by flashing these screens around. I'm going to go ahead and bring in my 2 over n, multiply it through, and so that would be 6 over n plus 8i over n. And now I'm going to feed the sum through. So that would be sum of 6 over n plus the sum of 8i over n. Now the 6 over n does not depend on I, right, which is my index. So I could actually factor that out of the sum. And so I can rewrite this then as 6 over n times the sum I equals 1 to n of 1 plus, I can factor out the 8 over n just like I did with the 6 over n. And then this would be the sum of I equals 1 to n of I. Good. Now this is where the formulas come into play that we had last time. So this formula, if I sum 1 n times, that's 1 plus 1 plus 1 plus 1. That's going to be n, right? Plus 8 over n. And then the sum of I, going from 1 to n, is, do you remember? You don't have to. We're not needing to memorize that. Oops, I think I forgot a square there, didn't I? Let me put that square in. And the sum of I is n times n plus 1 over 2. Now, I'm going to tell you these formulas, by the way. You don't have to memorize those. Okay? Good. And so now we can simplify that a little bit. So the area using n rectangles is going to be 6 plus 4. One of the n's cancels, and I'll just have n plus 1 over n. Good. And so now if I want the exact area, right, I would take the limit as n goes to infinity of a sub n, which is 6 plus, oops. Well, you can see here the limit of this term is going to just be 4. So it's going to end up being just 6 plus 4, which is 10. And you might remember that 10 is the number that we got up here. Okay, so that is the area under the curve. Now this was simple enough that we could just use geometry, but a lot of times these functions aren't that simple, and so then we'll have to do a little bit of algebra. Good. All right, I think we're ready now for the main definition of this section. So definition. Let f be a function defined on an interval AB. We subdivide the interval into n subintervals. And then we're going to talk about the area using those n subintervals. And I'm going to always use right endpoints, although the book doesn't. And so let xi star be a point in the ith interval to compute the height of the rectangle. Then this funny symbol here, this is actually let me rewrite that since it's the first time we've written it. A to b f of x dx, this is called the integral from a to b of f of x dx, is equal to the limit as n goes to infinity of the sum I equals 1 to n of f of xi star times delta x, provided that the limit exists. Good. So this is called the integral. Okay, and we're going to pause here and set up the next video. And we'll talk about this notation more, and actually we'll talk about some interpretations in terms of the geometry of the right-hand side as well. Okay, see you then.